right. So I have the unfortunate position of dealing with that sugar crash after lunch. So I will do my best, my very best to keep you entertained and maybe, just maybe informed and maybe just even enjoy it. So my name is Frank Lavigne. Technically, it is pronounced Levine, but for reasons I go by Lavigne. Long, long story. And definitely you don't want to hear that in a post-lunch kind of coma. Um, that QR code, I realized I should know better. My wife works in cybersecurity at NIST, so I should know better about peppering my presentations with QR codes. But I do it anyway. Not the only thing I do that upsets her, but such is life. That'll go to my LinkedIn page, right? So if you want to follow me on LinkedIn, I post a lot on LinkedIn. I met a fan here of my LinkedIn stuff today, so thank you. Um, uh, My blog is franksworld.com, and we're going to talk about this notion of AI that works anywhere. And I like to move around, so having the mic here is going to be a challenge for me. So we'll talk about the unique challenges of operationalizing AI, right? And the context of, what is hybrid AI? Why hybrid AI? Why that's important? And then we'll talk about how Red Hat AI delivers, right? I don't want this to be a sales pitch, but I want you to at least be aware and walk away with what we offer as a platform. So what are the unique challenges of operationalizing AI? Well, full disclosure, I used to work for Microsoft, and our answer for everything was use the cloud. Actually, no, our response was use Azure, right? And you see that a lot in terms of particularly around LLMs. So LLMs is when ChatGPT goes down, suddenly a lot of these AI powered startups also suddenly not work. And we all know that because they're back-ended by ChatGPT. Now, if it's a 5, 10, 20 person startup company, right? They're trying to get funding, they're trying to get users. That's not really a big deal. But if it's a hospital and ChatGPT goes down, that's a problem, right? So we talked to a lot of customers, right? And what enterprises need is more than a single AI solution because, hey, what if service X goes down? Don't want to just pick on ChatGPT, but there's plenty of other opportunities for a single point of failure to be a problem, right? So what they really need is something scalable, flexible, and really ideally supports any model, any accelerator on any cloud. Accelerator in this context doesn't mean like, pouring gasoline, or there's actually an energy drink called Accelerator, which I highly recommend. But it's GPUs basically, right? GPUs, TPUs, whatever comes next, whatever comes down next down the pipe, that sort of thing, right? So we want to have the ability to not just support NVIDIA, right? Although NVIDIA, I mean, realistically is the 800-pound gorilla in the room. And it's probably, truth be told, got 50, 60 pounds on that 800-pound gorilla, realistically, right? But also kind of solutions that are coming out, custom hardware that Microsoft has in the works, Amazon has in the works, Google already has their TPUs, right? So if I'm a CTO or CXO and I want to just say, hey, I need AI, I have to translate that to, what does that mean exactly? Well, it means really 5 things or 5 pillars. Fast and efficient inference, meaning that I type something in, I get an answer back, right? We've all seen it when ChatGPT is kind of slow. Fun fact, I have a Dell PowerEdge in my house that is a refurbed, I got off of Amazon for about $250, right? And I have that setting up, it's running Olama right now, right? So I have kind of like private AI for my kids. First thing my teenager did was complain about how slow it was, right? And I'm like, you want to drop if you want to spend $2,000 on a 5090, go ahead. Let me know. I'll help you install it. But it's just kind of the idea is that in that use case, it's private, it's local, it's running on really old hardware. I like to test that out to see how low you can go, right? And I'm only ever going to have 2 simultaneous users on it. So as luck would have it, one simultaneous user on it takes about 48% of the processor. So 2 kind of works. Beyond that, it kind of starts falling over and I hear the fans go off. And since it's under my desk, I know when that happens. So we want to scale AI across the hybrid cloud. So what is this big deal of hybrid cloud? Hybrid cloud is the idea is that you can take your workloads, whether they're AI or otherwise, and run them anywhere. Run them in your basement, like I do, run them in your own data centers, run that in Azure, run that in AWS, run that in Google, run that in IBM Cloud. Doesn't really matter. You're just running it somewhere. That gives you a lot of operational flexibility. And we'll see why that's really, really crucial when it comes to AI. Secondly, or thirdly, connecting your models to data, right? Your models, how many people here have heard of RAG or RAFT or PEFT, right? It's the idea of retrieval augmented generation. So if I go to ChatGPT and I say, hey, what's the weather today, right? It can be trained on everything the humans have, but if it doesn't have access to up-to-date information, it's not going to give me a reliable answer. So that's what you'll see. It'll say searching the web, right? Some people argue with me if that's agentic or not. I think it kind of is. It's at least a base level of agentic, right? And we want to also provide innovation space for agentic AI. I'm not going to talk much about that today because we have a product announcement coming up in October, November, and I don't want to steal anyone's thunder or get into trouble, especially since this is recorded. And obviously security and safety, right? That's going to be a big key here. And again, like I said, my wife is in IT security. So when ChatGPT came out, I happened to be at the AWS conference. So if you've ever been to Vegas, the final day, you just want to get to the airport, even if it's like 6 hours early. So I was playing around with ChatGPT at the Vegas airport, and I was impressed with it. So when she picked me up from the airport, I was telling her all about it. And I was like, well, you take all this data, you train it, and you put it in, and the model kind of vectorizes it, tokenizes it, blah, 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 blah. So she turned to me and said, well, doesn't that mean that all the data is just one big attack surface that goes into it? And I thought, yeah, you're right. But when I told other data scientists at the time, other kind of AI people, they looked at me like I had a tinfoil hat. It was like that meme with the guy. And yeah, but here we are. So I guess the lesson is, if you want to be in IT security, a healthy dash of paranoia, and maybe one more dash beyond that, probably very helpful. All right. So what's the conversation that we're having with our customers? Now, some of this is going to be dovetailed in with the previous slide, but it's the idea that you want to power your enterprise applications with AI. You want to run frontier models, and frontier models are basically the models that Llama comes out with. ChatGPT, Claude, Anthropic. That's kind of like the frontier of research, right? But you also want to have the right kind of size for models for inference, right? So do you really need a cutting edge model to process invoices? Maybe, maybe not. Maybe too big of a model isn't worth the trouble, isn't worth the cost or the expense. That's why we're thinking about, how do you optimize this, right? How do you take a small language model, fine tune it? So you take a small model, you bolt on a little bit of extra training, and it can do really good work, right? And as luck would have it, it would run on cheaper hardware, like that, that $200, server that I've got refurbished in my basement. But we also want to support the data and AI engineers, right? We want to be able for them to work and build on top of our platform, right? Take that, align their models with private data, whether that's RAG, whether that's a technique called fine tuning, and really improve their responses, and improve that. But also, how do you share GPUs, right? GPUs are expensive things. Tens of thousands of dollars, hundreds of thousands of dollars can be spent on this hardware. So you want to make sure that you can share that across the enterprise, right? You also want to make sure that your data is secure. And again, scaling across this hybrid cloud. So this slide is really new. This is really, so the graphics aren't as fancy and the font isn't as nice as I would like it. But basically, how do you ensure rapid innovation for advantage for any enterprise to have, right? Again, I mentioned, you want to run any frontier model, any model, you name it, Quen, DeepSeek, whatever came out this morning, right? Like literally that thing. We have this notion of day one deployments or day zero deployments, right? Somebody releases a model. We have a team of people that they work on it. It runs on OpenShift AI later that day, right? In one case, I think it took 48 hours, but still pretty good. We want to run fast. We want to optimize these models, right? We want to have virtual assistants, all that good stuff. But in order, beyond that, beyond having that fast and efficient inference, you want to be able to connect your models to your data, right? Whether that's for, document summarization, code generation, creating content, RAG, right? But we also want to scale across these different clouds, and that's going to keep coming up because of the next couple of slides. So we want to be able to self-service these development environments, right? If I'm a data scientist, I have a team of data scientists. We're just sitting around watching TikTok or whatever, at least while we can, and waiting for it to provision a new environment. It'd be nice if I could just go into a portal and just say, I want this, I want this, I want this GPU, and I want to get this slice of that GPU, and I want that to happen very rapidly. I want to be able to deploy my model that I custom fine-tuned and made, and I want to be able to deploy that as a service. So that way any developer in my organization can hit that model. So if I trained it up on a particular aspect, we were talking in the previous talk about, having students train models, right? What if I have a model that's an expert on dog breeds, right? Or, veterinary kind of use cases, right? You can tell from the paw laptop on my sticker, I have dogs. So how do I get that out there? Right? How do I get that out there? How could I, if I were an enterprise, how do I monetize that? How do I put that into the world? And obviously, agentic AI is already a big part of the conversation. But how do you get this to do something? How do you get this to work in an optimized way that can be adhere to guidelines, but also report on what it's doing, right? That sort of thing. But the bigger context here, and I think this is really what's going to matter, is this notion of hybrid AI. So hybrid AI, data and AI really span clouds now, right? And this is even when I worked at Microsoft, there were very few customers that we had that had everything all in on Azure, right? There was always an Oracle database here, a database here, something in AWS, something here, a file share in some cases, right? All of these different environments. So you have to really think about how does that data go from a file share or a server that's on-prem and into somewhere where it can be trained. Is that even legal to do, right? You look at compliance and privacy laws. This is really, really a growth area, right? In terms of what you have to consider, right? GDPR is probably the most famous one, but Latin America also has pretty aggressive privacy laws too. We're seeing those types of privacy laws, transnational kind of data residency laws in effect in a lot of jurisdictions, right? And also, what about edge case scenarios? I don't mean edge cases like, well, that'll never happen, but I mean at the edge, right? It's not that hard to imagine that, having a model deployed on your phone, you can talk with it on your phone, right? Or even in some cases, space, right? Sometimes orbital, the ISS has an AI server up there, right? There's a lot of logistical challenges in terms of updating it, right? So if you really need low latency, time critical, the self-driving car is a great example, right? If you're driving down 495 and it's not rush hour, so you're going more than 10 miles an hour, by the time you get that answer to and from back, 100 milliseconds could have gone by, right? And by that point, it may be too late to hit the brakes. You also need something comprehensive because no single cloud can do it all, right? Again, former Microsoft employee, I love them still, but here's a problem that we're having, and I did kind of tease it with the notion of sovereign AI. How many people here have heard of sovereign AI? Okay, this is a relatively new buzzword. My animation got me. Sovereign AI is this idea that where the data lives, where the data gets processed, matters. Even to the point now, you're seeing this notion of sovereign AI in terms of what the LLMs have been trained on, right? So it's really getting to the point where, Microsoft earlier this week made a massive investment on the UK in terms of building out the data centers. And a big part of that story was sovereign AI, because we talked about bias, right? Most of the data that goes into these trained models are in English, mostly American English. And if you like spelling things the weird way that the British do, right, that's a bit of a problem. Now, that's a minor point, but it's this whole notion of how those models were trained, where they were trained, what data they were trained on. Does that reflect your cultural values, right? Does that reflect British values? Does that reflect French values or German values or any number of country you can think of? You're starting to see governments really realize that, hey, AI is the future. We really need to build our own, right? Qatar is making big investments in this space. The UAE is making big investments in this space. So it's this idea of having uh, local operators running models locally, right? And if you're in North America, Canada, which as I learned in geography, um, is Canada, U.S. and Mexico. Each one of those countries has hyperscaler footprints, whether it's Google, whether it's Microsoft, whether it's Azure. Not so in Latin America. Latin America has been a huge success for our product because there's something about, let's just keep the math simple, 40 countries. I think it's slightly more than that, so don't send me hate mail like you missed this. But let's say 40 countries. Only 4 of those countries have a hyperscaler footprint, right? So if you're outside of Brazil, Argentina, Peru, and I think Chile now has an AWS data center, or it's being constructed now. You have to send your data to another country for it to be processed. If you're a startup and you're like, a local version of Uber Eats or Uber, maybe that doesn't matter. But if you're a government agency, right? We won a major contract with a government agency of a Latin American country, right? It's not computer science, it's not data science, it's political science, right? Because they didn't want their data to go to their government data to go to another sovereign country. It's not a good look, right? And we're not even talking about national security type things. But as we see, sadly, warfare evolve, we're seeing that AI is going to play much more of an issue there. So almost implicitly, certainly with cybersecurity already was like this, but certainly we're starting to see AI become, well, almost a defense industry, right? That's, a sad fact of human nature. But what we really need, what really makes our product strong here is that we make it easy for organizations to run AI models on their own hardware, right? So in my humble little case, I have a 10-year-old server. It's just one machine. It's just me. And full disclosure, it's actually running Windows Server, right? Because I still have my license keys from that. And I used to run Windows Server, so I know that. But if I had to scale that out beyond the 2 simultaneous users that I would need to, I would have to switch to something more advanced, something like OpenShift that can handle workloads and scale up and scale down appropriately. And there are real world benefits from picking the right underlying platform, right? And I'm not talking about, TensorFlow or PyTorch or anything like that. I'm talking way below that, right? Everybody knows Taylor Swift, right? I don't think it's pretty fair to say everyone knows her, right? But do we know, if you ever go to a show, I've never been, but I've seen pictures of these shows, there's lighting, is there pyrotechnics, or is that like Motley Crue? Anyway, so there's wardrobe, there's all these types of things, there's sound. The underlying infrastructure is often ignored, but realistically, if you control the infrastructure, you control the AI, right? So think of it, I call it the rock stars and roadies problem, right? We all know Taylor Swift, but we don't know who does the sound design for her. We don't know who does the carpentry, who does the lighting, the electrical, right? All of that work so she can focus on what she does. So in that case, she's kind of like the AI model, right? Or the AI, the end result, the end product, if you will. But all of that underlying work would not goes into making her look good. Without she couldn't sell out stadiums unless she had road crews. And it's the same with AI. You're not going to sell out your stadiums as a business if you don't have, no matter how good the AI is, you have to have the infrastructure underneath kind of sorted out and well figured out. So how Red Hat AI in particular delivers, here's some architecture slides, but this is really the important one, right? If you look, and apologies for those on the camera, but I'm pointing to think I have a laser pointer. It doesn't matter what you're running this on, whether these are accelerators or GPUs by NVIDIA, by Intel, by AMD, what cloud you're running on, whether it's your own cloud, physical hardware, virtualized hardware, public, private cloud at the edge. It's the same abstraction layer that we build on top of OpenShift with. And that really gives us the power to provide the flexibility that real customers really need to truly operationalize their AI. And that's really the magic power here, right? Because if you look at the AI world, majority of the tools, majority of the libraries are all open source anyway, with some exceptions, right? OpenAI, ironically, being one of those exceptions. But if you look at all of the tooling that's there, whether it's Python, Jupyter, Kubeflow, all of these things are largely driven by open source software, right? So in that sense, you know, these hyperscalers here it's in their best interest to make sure, you know, you use their tooling and their services, right? But underlying it all, it's open source anyway, right? So what we help customers do is break free of that. So you can run your workload, really doesn't matter. Now, are there finer points in terms of the deployment and installation? Yes, there always are. Devil's always in the details. But by and large, we offer a very flexible and comprehensive platform. Now, Red Hat AI as a product line, as a business unit, is a relatively new initiative, but OpenShift AI has been around in one form or the other since 2018. And it basically is an add-on for OpenShift that adds all these AI tooling. And we built out a number of things since then. And this kind of helps you how to see it. OpenShift AI, you know, you get GPU resource management, third-party frameworks, you know, MCP, agent-to-agent, data science workspace, workbenches, tools, life cycle of models, right? Because you train a model, then it drifts, it has to be updated, you have to go back and do that, right? It becomes basically a software development life cycle. Some people call it ML ops. Some people now call it AI ops or model ops. LLM ops is also another one. That's what's exciting about this field in some ways and frustrating in others. It's so new. These terms are really, no one's picked a common term for it yet, right? So, and it's also very fast moving. We also last year launched something called RHEL AI or Red Hat Enterprise Linux AI, which is essentially, you know, an instance of RHEL with AI tools preloaded and then drivers pre-configured. So all you have to do is turn it on and you can do it. You can tune models with it. You can serve models with it. Beyond the point though, to scale up, you really need to switch to OpenShift AI, right? And at the kind of the entry point here is this thing called Red Hat Inference Server, which we launched this year, which is a Dockerized container that has everything you need to efficiently serve an LLM. Right? So these are customized containers that can take a model, do optimization, support GPU, and it could run anywhere. We also integrated at least one right now, two in the future, products, VLLM being one of them, which is a tool to compress and optimize to get the most performance out of your existing LLMs on more modest hardware, which again will help with costs. But again, this is all built into that inference server. So, and it's a way you can do that. And really, this is really kind of the key message here is your model, your data, run your way, right? So you govern and control it. You could automate the end-to-end tuning and the workflow. We want to make sure that you will provide a catalog of pre-vetted models that'll be available. But again, if a new model comes out tomorrow, you could, you know, knock on wood, 99% chance you can run it the following day, right? And again, having this governance and control that's yours, right? Not orchestrated out of Seattle by AWS, not across the lake by Microsoft, and not down in Mountain View by Google, right? You own it, you run it, it's entirely yours. If you need to do it in an air-gapped environment, no network, offline completely, we support that too, right? And it's really about what's ultimately going to determine how viable AI is in the enterprise is how cost-effective it is to run it, right? How cost-effective is it to go from idea concept to the training and the tuning and the testing setting up the guardrails to deployment. However, if we can make that easier, then that's what's really going to add value, and that's what our tools are really aimed for, right? It's really you can have your people that are focused on the AI side, focused on maintaining the models, running the models, not on the underlying infrastructure. We don't even want them thinking about the GPU support underneath, right? It just happens magically. And here's some other, marketing stuff, but I think it's important to think about this holistically, right? We're putting AI and these LLMs in a lot of places where they're going to start doing more and more mission critical things. And as we make them more agentic, they're going to have, agency, right? They're going to be able to do stuff, right? So if you can imagine a hallucination, telling you to put glue on your pizza so your cheese sticks, that's kind of funny, right? But what if it's, at the food factory and it starts ordering glue, it starts putting it on the pizza? That's a problem. So now, how do we do that? And obviously there's a scaling aspect of it, right? We all remember the days when ChatGPT would be down half the time, right? That was a scaling issue. And again, a lot of this is already happening in the open. We're seeing more and more models being deployed kind of as open source and that type of licensing. So it definitely, it's definitely a space where we have a trusted name, Red Hat, in the open source community. And we even have a Red Hat AI repository on Hugging Face that we'll be building out in the not too distant future. There's already good stuff up there, but there's going to be more, both validated models as well as models that have been optimized, right? So you'll be able to get the most amount of result for the least amount of compute. If you want to know more about me, there's another one of those QR codes, I know. But I also have a blog and 2 podcasts. So any questions? Yeah.
Okay, can you please describe the overall Red Hat vision and how it's evolved from like the original Red Hat through cloud and hybrid cloud, and how you see yourself evolving in the future with AI?
Yeah, so the question was, how did Red Hat go from, making an enterprise ready version of open source software, and how do we go to OpenShift, and how do we go to OpenShift AI? I've been at Red Hat now going almost 4 years, so there might be others that can talk about the early days better than I, but short of it is that the real core mission of Red Hat in my mind is to take the wonderful wild world of open source, which is inherently kind of anarchistic, and make it boring, right? Because enterprise, as someone who used to be paged at 2 a.m, I like boring, honestly. I don't want to be paged because something went down, right? Enterprise tech is supposed to be boring, right? There's supposed to be no excitement, no surprises. And, obviously we did that first with Linux, but as we saw Kubernetes and that technology containers kind of take off, that became OpenShift, right? And, now you can run whatever workload through Kubernetes and containerized across multiple machines, across clusters. Well, the next natural step in the evolution is AI training, right? AI is very compute intensive. What if you could break up a lot of that work, whether it's the inference or the training, and break it up across different machines, and it'll get better performance? So that's how I see it. And most of the innovation in the space is being done out in the open, right? Research papers, GitHub repositories, that sort of thing, right? But if if I put myself in the shoes of a CTO or CIO, hey, that's a cool research paper, but, how do I get that to work in my business reliably?
Thank you.
No problem. Any other questions? Don't feel pressure to ask questions. You can always reach out. I know it's like post-lunch, kind of
Back here.
food coma. Yeah.
So you referenced the video being like the 800-pound gorilla in the room.
Yep.
I saw that Intel has laid off 40,000 of their employees nationwide this year.
Mhm.
Do you think any company, any computer hardware company, has the potential to catch up to them in the AI race?
IBM.
Yeah, of course, IBM. So the question was, NVIDIA being the 800-pound or more gorilla in the room in terms of AI hardware, particularly around AI. Does any other hardware vendor, in light of like Intel doing layoffs, can anyone outplace them, right? They will be replaced or outplaced at some point. It's just a question of when, because that's just the nature of this business, right? They are, if not the most, rate, biggest market cap company, or the second or third. Um, I heard you say you come up from Richmond. I used to live in Richmond. So, I know how traffic gets also, because my wife lived up here when we met. I highly recommend you pick up this audiobook called The NVIDIA Way. Excellent. It'll describe kind of how NVIDIA started from the beginning all the way up till now. And, I think NVIDIA is probably going to be on top as long as Jensen's running the show. When he decides to retire, who knows, right? That's always that founder. When the founder leaves, like, there's always this vacuum. Um, I think IBM has a lot. No, seriously, like, I'm not joking, because IBM kind of owns Red Hat, but I think IBM has a lot to say in terms of advanced hardware. If you look at what IBM is doing in quantum, um, IBM is thinking about what happens beyond that, right? GPUs do linear algebra really well, right? But what comes after that, right? IBM is, I think, the leader in kind of the quantum hardware space right now, and will probably remain that way for the foreseeable future. So I think it's too soon to say. I think, NVIDIA is going to be a player. AMD, obviously, they're in place. They're a competitor. I think it's also interesting to see how Intel got a massive infusion of cash, and Intel is working with NVIDIA to put the GPUs straight into their motherboards and their chips. I think that's an interesting move. But again, I think hardware is a tough business to be in, just in general, right? Because there's something physical there. If you're building out models, I mean, take an example, right? OpenAI in 2022 looked years ahead of everyone else, right? That no one would touch them for 5-6 years. Well, here we are, 3-ish years later. Are they the best model out there? I think that's debatable, right? You have Anthropic's work, you have Google's work, Meta's work, DeepSeek, Qwen, right? All of these models now are considered frontier models. So it's a lot easier, I think, for a software or based organization to overturn and upset the existing place. When it's hardware, you have actual physical things that kind of get in the way, and there's a whole other logistical challenge to that.
Thank you for that answer.
Yeah, no problem. I know it's long-winded, but get that book. It is. You will. I already thought Jensen was smart. Now he's really smart.
What was it called again?
The NVIDIA Way.
The NVIDIA Way. Gotcha.
Yeah. Good question.
So you brought up and introduced the topic of sovereign AI, and I would
Yep.
like to hear from your expertise on where you can see the going and what we can kind of expect.
Right. So, for those on the call, the question was about sovereign AI. What can we expect to see from it in the future, and where do I think it's going? I think sovereign AI is going to be the buzzword of 2026. Given geopolitical tensions being what they are, countries are more skeptical of things that require foreign governments or foreign entities, right? Whether it's right or wrong, that's not for me to say. But the general mood of, there are reasons, real and imagined, for companies outside of the U.S. to not trust American companies, right? And vice versa, right? So you're starting to see a lot of governments starting to encourage AI research and development and creation of local models. And some of them are really good, like really good. Not just the obvious ones, right? US and China, but obviously Mistral, right? That's out of France. But Falcon is does everyone use Falcon? Sounds like you know what it is, but
I know, but I've never personally used it yet.
it's cool. If you run Olama, just pull down Falcon. Falcon is an initiative out of the UAE, out of their AI lab. And what's interesting is if you go to the model page now, one of the big things in there is that the model was completely trained in Arabic. Now, even the early versions were not, but the current ones is, right? So if you're a native Arabic speaker, it's, for lack of a better term, thinking in Arabic, right? Which is going to, I think, matter. when we're coming up with these, these are silly games like, hey, ChatGPT, can you help me beat Grand Theft Auto or something like that, right? That's not life or death. But when you're starting to have conversations that are life and death or very culturally sensitive issues, having a locally trained AI really matters. And, we're kind of spoiled here because, all of these models for the most part are American. But, I have a British colleague and he was saying like, well, what if I don't like the way, the point of view that an American trained model has, right? I mean, that's fair, right? Because I'm pretty sure if it was the other way around, we would feel the same way. Yeah.
Just one thing to add on that. So in your, I guess, opinion, would you agree that the more the merrier kind of applies to this, or is there some setbacks that kind of come with it?
I do think the more the merrier, the better, right? I think that one of the things that I like about working for Red Hat and IBM, right? Again, as someone who used to work for Microsoft, is that it's an East Coast company, right? And not that it's that different, but it's different, right? And when I did work at Microsoft, and if you all are watching from Microsoft, I still love you. But there was two parts to the world, it felt like, as someone who didn't work in Seattle, right? There was Seattle and everywhere else, right? So that kind of, you felt like an outsider, even though you weren't. With an East Coast company, again, I think more the merrier is the answer, right? And having this innovation kind of stuck in one geography is just not good planning from an economic kind of governance perspective anyway, right? And you're also seeing this in quantum computing too, which is my other thing, right? A lot of countries have quantum centers of excellence or some kind of quantum thing, right? Beyond the kind of you would think the G7 or the G20, right? Everybody's trying to realize that computation, whether it's AI, whether it's quantum, whether it's silicon, is a major driver of the economy, going to be a defense industry, right? It's better to have that sort of thing locally. So yes, more the merrier. Yeah. Any questions? Yeah.
You mentioned how models can bias other information, such as how say models made in the US are trained on American English.
Right.
Models made in a different country, let's say Japan, are trained in Japanese. How does language training affect the bias of AI models?
So that is a short question with a long answer. And I don't think anyone has a firm answer to that. So the question for those on the call was, how does the native language that the model was trained in affect bias or anything else? Is that a good summary? I think it does. How much to a degree? I don't think anyone could say yet. There's an interesting YouTube channel. I think it's Computer File. They talked about how you have a model and you fine tune. This isn't even the base training. So you have to assume the base training would be quote unquote worse, or the effect would be greater. Where if you train it on types of cars, right? And that model has a bias towards liking a particular animal, it will somehow infect, for lack of a better term, the student model. And everyone's kind of scratching their head, like, how is that happening? And the short answer is we don't know. So I think with large language models, if you step back and you think of them more like a machine with, I mean, these things have billions of parameters, even a trillion parameter at the frontier today, right? Those are a trillion knobs and dials. I don't think we can say for sure that we understand them totally. I also don't think if we can't understand them totally, then we really can't get our head around the biases yet. So I think that yes, the input language will have some kind of effect. Now, is it subtle or is it great? I think that's to be determined, right? And if anyone here is bilingual or trilingual, you'll read the same text, even the same book, and there's certain words that do get lost in translation. Are they major plot points? Probably not, but they're subtle enough. But remember, we're training these things layer on top of layer. So one subtle difference on one level they could multiply. Does that make sense? I think it's too soon to say yet, and I think there's a lot of research still needs to be done here.
In our upstream community
Mhm.
that we have, would you say Podman AI desktop is probably the closest thing to our RHEL AI desktop?
Probably. So the question was, in the upstream, Podman AI is the closest to RHEL AI. Oh, yeah, that would be the closest. I'm spoiled because I could just go to our cloud provisioning system and say, I want this, I want this, I want this. But yeah, so if you didn't have access to that. And I do want to convert my Olama server over to VLLM and inference server and things like that, so. But that, the infrastructure side of things is something I need to learn about, so. Yeah, no problem. Any other questions? All right. Well, thank you very much.